Commander King here, and this time we're taking a look at resonance structure. So resonance structure is just a fancy term for elements that have the same skeletal structure. In other words, the atoms are in the same order, but the electrons are distributed differently. So let's take an example. From the last video, we know CO2, we drew it like this. So we had the CO2 like this, okay? And we said, hey, that was our answer because all of these atoms fulfill the octet rule. In other words, they all have 8 electrons that they're sharing around them. And we used up all our valence electrons. So your valence electrons were all distributed. Okay. But there's another way that these atoms could distribute their electrons, and that's what we call the resonance structure. So there's another way where we can have the same skeletal structure of OCO and still have all the elements follow the octet rule and have the valence electrons distributed, which last time I believe we said there were 16 electrons going in. So let's think about how we can do that. So one thing we could try is it doesn't seem like there's much flexibility, right? But one thing we could try is maybe putting a triple bond here. So if I try putting a triple bond here, let's just think about that for a second. That means I couldn't have a double bond here. Otherwise, I would have 2, 4, 6, 8, 10. And that wouldn't be good. So I know that can't be it. So I'm going to leave the single bond here so that the C is happy. All right. And then I'm going to fill in my electrons from there. So I know I've put in 2, 4, 6, 8 electrons so far out of my 16. I know I have 8 more electrons I can put in. Well, let's make this O happy because we see that it's sharing 2, 4, 6 electrons to fulfill the octet rule where it needs 8. I only need 2 more electrons. Okay, so I put 2 more electrons there. So that's reasonably happy. And now I'm looking here and I'm saying, okay, well, this only has 1 bond here, which means it has 2 electrons. Again, to fulfill the octet rule of 8 electrons, I need to put 6 more. So I'm going to put 1, 2, 3, 4, 5, 6 electrons. Okay, and now let's just make sure. This O has 8 electrons around it. That's good. This O has 8 electrons, and this C has 8 electrons. So the octet rule seems to be fulfilled by every element. And the other thing I need to think about is, did I use up all 16 of my electrons, that these valence electrons that my atoms put in? Well, 2, 4, 6, 8, 10, 12, 14, 16. I have 16 valence electrons, which is how many I put in. So this checks out. So what this really means in chemical terms is that CO2, sometimes, okay, the bonds can be distributed like this, okay? And sometimes the bonding might be distributed more like this. These are both viable structures and seem reasonable for now. And in reality, the compounds actually does spend time in each of these scenarios, or more closely to each of these scenarios. But there is a better one, and that's what we'll look at next time with formal charges.